So
is being recorded.
Go for it, Graham.
Okay, so thank you. So the goal of this meeting is to prepare for the reading in Albuquerque. I had an email exchange with Martin a couple of weeks ago, and he asked me to prepare a couple of slides for this virtual meeting. So I'm going to show you the slides. So the main goal is to, we had a lot of meetings of teleconferences in the working group, and there are a couple of questions we are not sure about what the answer should be. So we would like to have more feedback from the whole forum in general to be able to answer this question. So that's the main purpose of this meeting. And also, if we have some time, and if people are okay with that, maybe we can make a pre-reading of what we have so far, so that you can make a comment. The text is not very long, so it shouldn't take too much time, and feedback would be much appreciated, actually. So I'm going to show you the couple of slides I prepared. I can't share my screen. Why is that?
Sometimes trying to share individual applications doesn't work as well as just sharing the whole screen, if that's what you're trying to do.
But okay, application. Okay, maybe I'm going to do that. But it's the same. I can't share anything. It was working. It was working a couple of minutes ago, and now it's not working anymore. I don't understand.
Try taking away the presenter and then giving it back.
Yeah. Okay. No, it's okay. Okay. I think I changed the permissions. It should be okay. Let me. Oh, okay. I think I'm good.
Yeah.
Yeah, you can see my screen now?
Well, it started to, and now I just see a white screen. It does say we're viewing your screen, but it's just a white screen.
You don't see the slides. Okay. Okay. Maybe I'm trying to share a single application instead. Let me do that. Let me do that. Which one is it? I'm not okay. I've got a zillion of application open, so it's no. Okay. Where is it? Can you see something now?
So far, still just a white screen.
Is it
Yes.
okay? Can you see the slides?
Yep.
Okay.
Yes.
Okay, so maybe I'm going to skip up the first slides. So basically, it's for okay. If people do not know what we are what we are going to talk about today, so maybe just a couple of information. So why we want to introduce some hardware management, topology management in MPI. So basically, architecture are increasingly complex. And the application developer need abstract features to understand how this hardware works. And they have to, right now, they have at their disposal some low-level tools such as HWLock, libnuma, etc. And it's really painful to use such tools in an application. I mean, such tools are more targeted for MPI implementation developers or runtime developers, but not really for application developers. And by taking into account the hardware, you can expect some performance improvements. So what are the needs? Currently, MPI does not offer satisfactory support for hardware locality and hardware knowledge. So what you have currently in the standard is the function MPI get processor name. You have the use of MPI com split type with the key value MPI com type shared. And then you can create some shared memory windows. So in this case, it's rather useful because when you have shared memory windows, you can bypass the whole MPI stack and use load and store instead of sending and receiving messages. So the MPI overhead is much reduced. You can also use neighborhood collectives, which gives you some. It's a way of sending and exchanging messages with your neighbor, but neighbor in a logical sense, not as far as the communication pattern is concerned, not really your physical neighbors, I would say. And maybe it would be possible also to use URIs from MPI sessions to have to gain some knowledge of how your processes are organized on your hardware. It's not yet available, and for applications that are forced to deal with communicators, it might not be possible to use MPI sessions at all. So what we are proposing is to standardize something that is already a common practice in some MPI implementations. So for instance, OpenMPI defines a lot of non-standard friendly split type values. And so it's a de facto support of the guided mode I'm going to present after. And MPitch already implements a kind of guided mode for the com split type with the help of the MPI com type neighborhood value. So from the implementer point of view, implementing this stuff will not be very difficult actually, because it's more or less it's already done in the current versions of the OpenMPI and MPitch. Plus there is an external library called HSplits that I wrote that is implementation agnostic, and it's a generic code. It's built on top of HWLock. And since OpenMPI and MPitch and most of MPI implementation already use HWLock, it would not be a lot of work to adapt this code to a specific implementation, I think. We already have users and use cases for that use these hardware-related features. For instance, hierarchically structured applications such as vector matrix multiplication or hierarchical matrix multiplication. So we showed instances of such application in a paper that we published 2 years ago. It was in EuroMPI in Chicago 2 years ago. Also, we have an interesting use case of dynamic placement of hybrid MPI plus OpenMPI applications. So that's for coupled applications, and when you have various kernels with their own placement policies. So it's useful in that case to be able to create communicators corresponding to hardware resources and to organize your threads and your processes according to these communicators. So we have a very nice ongoing collaboration with a research institute about that, and a lot of labs in the world dealing with mostly climate applications are interested in what we are currently proposing. So this could be very helpful. And the last point, which is very important to me, is I think that users need portability and perenniality of such mechanisms. So I had the remarks in Zurich that why should MPI do this stuff? Why not using another piece of software to do this? Maybe PMIX could do that instead of MPI. I think that HWLock, you can do that with HWLock, NetLock, or whatever, but I think it's not possible to do that. Well, it's possible technically, but I think it's not interesting for our users because they are developing MPI applications and they are not willing to use something else. And they probably won't use it anyway. So they need the nice thing about MPI is that it's a standard. And when they work in a constrained development environment, they need to be sure that the features they are using is going to be available in the forthcoming years. So they are very reluctant to use an external software to do that, to achieve that. And they are maybe not willing to mix MPI with something else. The original issue, number 132, was to introduce a new split type value called NPI ComType hardware subdomain. And there were two modes, the guided and the unguided. So the guided mode is when you specify an info key for to guide you for the splitting. So you give a name of the requested resource at which you want to do the splitting. So the key is MPI hardware subdomain type, and the value that you provide is a string, which is an implementation defined string. So the thing is that we don't want to standardize the names. We just want to standardize the way the names are accessed and used. And the unguided mode is when you don't provide this info key. Then we make a supplemental assumption about the hardware. We say that the hardware is, at least the hardware is viewed by the MPI implementation as hierarchically organized. And you split the input communicator into strictly smaller subcommunicators, which means that when you do a comparison with the oldcom and newcom, you get MPI unequal. If the communicator you create is valid, of course. So in Zurich, I made a reading of this, and it was decided that we had the feedback that maybe it was more interesting to split this into several tickets. The original issue now is just for the guided mode, and a new issue has been created because we thought it was maybe interesting to create a query function to get the types, the names of the resources that are available, that are provided by the MPI implementation, so that people can know which name they are going to be able to use in the guided mode. So once again, the goal is not to standardize the way the names are accessed, not the names themselves, because we had this debate about the split types, and we decided not to standardize a bunch of split type values. And there is also a new issue that is yet to be created that concerns the unguided mode only. So this text is not completely ready. It should be in the forthcoming days, I think, but I have a version of this that I can eventually show you if you wish. So we have some open questions for the guided mode. So the first question that is very important is that when we use the guided mode, the info object is not a hint, and it must be used by the implementation. It cannot be ignored. So this is a consequence of the two separate tickets for guided and unguided, because in a more global, if with a ticket that would encompass both unguided and guided mode, we would be saying that in case of the info object is not provided, then we switch to unguided instead guided. So the fact that the info is required, there's not just a hint, is a precedent in the standard. So the question is this an issue? I mean, how do people feel about that? Maybe it's not an issue if it's clearly specified in the proposed text, and this constraint might disappear if unguided is also accepted, which is not totally true, but it could be something like that. So Martin's answer to this question yesterday was that he thought it was a good thing that could maybe set a precedent and that could be useful for further for in the future for other extensions of the standard, and that he liked this idea. So what do you think? What people think about that?
So I'm okay with that if people go into that knowing that that's what we're doing. So the one alternative here would be that if you don't provide the key, then this would essentially act like a COM dupe or something. Is the reason you don't want to do that because that makes it harder to accept unguided in the future?
Oh, in that case, we would say that if you don't provide, in the text, we say that if the key is not provided, that the behavior is implementation dependent. So that leaves the door open for people that want to already support unguided to do so. And if people don't want to support this, they can do whatever they want. So that's what the text says.
I mean, in the notes I'd made when I was reading through this yesterday, that was the route I preferred, but I'm okay with setting the precedent for saying that an info key must be required. I mean, I guess I don't have really strong feelings about it. I don't know that we need to do it. If we don't need to do it, I don't know that we ought to. But if that's the forum's preference in general, that's okay, I guess. Okay, because there is something when you read the text about info keys, it says that they're optional. So yes, so that would be an exception to this rule. So I think that is not a problem as long as it is clearly stated in the text that it's an exception to this rule, and that it must be provided, and it can't be ignored by the implementation. So as long as it is clearly written, I think it's okay. Yeah, that's mainly my concern, is that you'd need to make that text very clear, both in the places where you've added it, but also you would need to go edit the text in the info key chapter or the info object chapter probably to make it clear that there is an exception to this rule and point to your new text. And I'm more confident that we could that we could be consistent by saying this is optional and you'll get implementation specific behavior, with the expectation that if we add unguided in the future, that'll make that implementation specific behavior defined. And if we go the other way and say that you must provide this value, then it's just, I think there's just more opportunities for us to miss things. And we're setting a precedent, which is fine, but we don't necessarily need to, so.
Okay.
Okay. Help me understand. Can I ask a question? Help me understand exactly what we're trying to say here is required. So we're talking about MPI COM split type. Yeah. With a new split type value of hardware domain. This is the guided mode.
Yes.
And if you're using the guided mode and you provide an info key, then the implementation must not ignore it.
Yes.
Okay. So I guess the exception here is that this new guided mode plus info keys would be added at the same time to implementations. Therefore, there would not be a compatibility issue if you were to provide these info keys to previous MPI implementations because they would not support the split type that you're attempting to use.
Come again, please.
Is that right?
Could you repeat your question? I didn't hear.
Yeah, I'm trying to understand because, I mean, if this were simply an info key that the users are now, providing that the implementations must respect, but you're using an old MPI implementation, then, it's totally out the window. That makes no sense. You can't enforce that. We should just strike it from the record. But I guess the carve out here that we have is that these keys only work with the new split type value, which is, which would presumably go in at the same time.
Yes.
So implementations would only support these keys for the new split type value. So I guess I'm understanding now how this could possibly work for compatibility's sake. I still don't love it, but I guess I see how it could work.
Okay.
I don't have any extra comment. I was just trying to clarify for myself.
Yeah. Okay. I'm just taking notes about that.
And I want to add to the original question. There's always a key value. The key for the rank numbers provided in the argument list. Not the key in the info, but the key in the argument list.
Yes.
And therefore, normally, if we duplicate a communicator, and then normally we have to do it based on these rules about rank reordering when we have different key values in the argument list. And what's here in this second block here on this slide is a question whether we should use a special return. This means a copy of COM handle. This means this is MPI ident with ignoring this key argument that we can really tell with this special return value on the communicator that we can tell this special case.
Yes, but I didn't. I have not spoken about this yet, Rolf. So we were just
okay.
yeah. It was just
okay.
Yeah. But that's a good transition.
I came later.
Late
with that.
It's okay. It's okay, Rolf. It's a perfect transition because the second question we have is what is the outcome for weird cases? So I sent an email. In my email, I have written the word error, which is not an error actually. I was thinking more about what happens when the function does not what is in the normal case, I would say. So what are the weird cases? What I label as weird cases. It's when the user provide a wrong info key value, not a wrong info key, but a wrong info key value. Then what happens when the info key value is ignored by the implementation? I think it's more or less the same thing. And more importantly, what happens when info key values are not consistent across calling MPI processes? So in that case, we would need to define the behavior for what is the outcome of the split type in that case. And the first question we want to know is having the same behavior for all these weird cases, is it okay or not? So should we make a distinction between the fact that the info key value was wrong or the key value is not consistent across all calling MPI processes? Is it okay to have the same behavior, or should we make the distinction between behaviors, between the cases? And if we have the single behavior, so we were thinking about two options. The first one would be to return a copy of the communicator handle, which means that when you do a compare, you have a API ident, or return a duplicate or a copy of the input communicator. So it's a duplicate or a copy based on what Rolf was saying just a couple of minutes ago. If it depends if we use the key parameter. If we don't use the key parameter, it's going to be a duplicate. So MPI compare outputs results in MPI congruent, or if its key is used, the key parameter of the split type function is used, then you would have MPI similar, which is not, strictly speaking, not a duplicate but a copy. So what do you think about that? I know that Martin doesn't like the idea of just copying the communicator handle. He would prefer to do a duplicate or a copy of the input communicator. The only problem I see with this is that it's possible with guided mode to create a communicator which is in the normal case. I would say not in a weird case, to have a communicator that corresponds to the input communicator. For instance, if you have a process, if you have processes that are bound to a package which features only one L3 cache and they want to split at the L3 cache level, then the output communicator is equivalent, is the same as the communicator. So in that case, we can't make the distinction between these cases of the weird cases and the normal cases that outputs an alias of the input communicator. So it's maybe it's a problem, maybe not. I don't know. I haven't a fixed idea about that.
What does ComSplit do if you provide if the value you provide isn't the same everywhere? Not this info key, but in the existing split, if the split type you provide isn't the same.
If the split type you provide is not the same, I don't know if it's. I don't know. Okay, maybe I
think my preference would probably be to do whatever that does, and I assume it's an error, but I don't know.
So if you don't provide, if all processes do not provide the same value for split type, you say. Let me check. It says that this is a collective call. All processes must provide the same split type.
So my thinking is we should just do the same sort of thing here and say everybody has to provide the same thing. And if you don't, then you're going to get undefined behavior, or we could return an error, but it's going to be implementation specific, and we just don't say anything about it.
Okay, so in case for all the cases, wrong info key value, ignored key value, and not consistent info key values, you say?
Yeah, well, so this kind of goes back to what I was saying about whether or not we require the info key. If we are going to require the info key and say it's an error if you don't provide it, then I think we should be consistent with the split type text and say everybody has to provide the same value for that info key, or it's an error. If we're not going to require that info key and we're going to say that if you don't provide it, then we're going to do something else, then I would say that this should be just entirely implementation specific, and perhaps not an error. I don't know, just because in that case all the keys would be optional.
But the Rolf raised a concern about the fact that consplit type is a costly function. So if you don't output a usable communicator, it's maybe not. It would be maybe a good thing to output a valid communicator, even in these cases. I mean, if you provide a duplicate of the input communicator, then you don't take much risk. But I don't know.
I disagree, because I think in that case you end up, I mean, yes, your application will still run, but you'll get weird behavior that you didn't expect because you thought that you were splitting your communicator in a certain way, and in reality you didn't because you provided incorrect input. And I don't think we should correct the user's input by just silently falling back to something else. I think we should say, this was an error, you did something wrong, and you should fix it. Or we just say that it's undefined. I mean, me, the fault tolerance / error handling guy, says, throw more errors, tell the user they did something wrong, they can fix the problem. The slightly more pragmatic MPI forum guy says, well, let's just make it undefined and maybe implementations will do that. But adding that requirement means you have to do the, you make the split that much more costly because you have to do a reduction first to make sure everybody has the same value for the split.
Yeah, exactly. Yes, I agree. I agree because you have to check for all the values provided. I agree with that. That's another problem. So,
I mean, it doesn't have to be that expensive to do that. You can piggyback that onto some other part of the operation probably. But the point is, I think the thing that's most consistent with the rest of the standard would be to say, if you provide, we should say that you're required to provide the same value at all ranks, and that's all we should say. Therefore, it's undefined what happens if you don't. But the expectation would be that if you don't provide the same value everywhere, things will probably crash.
Okay, so for the text, only something like all processes should provide the same info key value, and that's all.
All processes must provide the same value, the same way we say for
split type. Yeah, yes. Let me check the split type. It says all process must provide the same split type. Okay.
Yeah. Okay. That's my preference. Rolf, you have another opinion, so.
No, I like must.
Okay. Well, no, I meant just on the whole proposal. It sounded like you preferred to do more of a dupe thing.
No.
At some point, because at
the most simple is that we define this must be done, and all other things are undefined. Yeah.
Okay, so because at some point, instead of outputting a communicator, we were returning com null. And so that was a concern for Rolf, I think, because he thought that, okay, if you have com null, it's maybe a pity to output a null communicator because the function is costly. So then we discussed about that, and we had the idea of copying the input communicator so that people can use it anyway. So yes, it was. So we can always say that it's undefined behavior. So okay, I'm okay, completely okay with that. It simplifies the text to some extent. So it's. So has anybody another idea or another thinking about that? So what I'm going to do is maybe I'm going to write some text with several options and yeah, I don't know.
Your intention is to read this in December?
Yes.
Okay. I mean, we can do polls over email or something.
Yes.
I don't know.
Yes. The idea would be, okay, so the idea is to what we want to do, what we would like to do is to have at least the guided mode in MPI 4.0. Maybe if we need it and if the text is ready to have the query function, but it's something we are going to discuss just after. And if we manage to have something ready for unguided, because there were a lot of discussion about unguided, also to have unguided in December. So that would be the plan. We would like to have the guided mode in there. So
Okay.
So what I would probably do is when things are ready to maybe send an email for people to check the text and get some feedback from the whole forum again when the things are very well advanced. So so now we have maybe an issue, maybe not, I don't know, about the user provided info key value. So let's imagine for a second that, okay, the info key is provided. The user provides info key values that are consistent across all calling MPI processes. So everything is fine. So, but how the user can know what key value can be used? So the question is, should we provide a function to retrieve the list of possible names? So there are two answers, yes, no, and yes, now. Should we do this now or maybe later? So should we push to do this for the December meeting or not? That's maybe the question. And then there is a question about what kind of design should we adopt for such function? Because we were thinking about either a local version or a collective version of the function. And
sorry.
Yeah.
Before we continue on this, I was just looking through my notes again. There was one more thing I wanted to say about the weird cases.
Yeah, go ahead.
So we were talking about inconsistent values across all processes, but I think we might want to have a different behavior for the wrong info key value. Because if you don't allow the info key to be something that the implementation doesn't know what to do with, then you're going to have issues across implementations.
Okay.
If you take an application and run it with MPICH, and you take the same application and run it with OpenMPI, and MPICH accepts one set of keys or values, and OpenMPI accepts another, then you could have issues there. As I say this, I realize this is somewhat inconsistent with my argument of we should tell the user when they have something when they're going to get something they don't expect, but we might want to consider not making that an error and saying that will dupe the communicator or something else, because that's more of you might not have written incorrect code in MPI, but you might be using a key that MPICH doesn't know how to deal with.
Yeah. Okay. So that might
be worth a little more discussion.
Sorry, come again?
I was just saying that might be worth a little more discussion. I don't know that I have a strong opinion yet on which way we should go, but I'm not entirely sure we should just say that's undefined as well. Yeah.
Okay. So maybe I don't have, as I mentioned previously, I don't have I see your point. I think your point is a fair one. Maybe yes, a wrong info key would be in that case to duplicate the communicator, because okay, and then for non-consistent, just say that the same value should be provided, and if not, it's the undefined behavior. Okay, I'm okay with that. It's really an open question, so I'm not sure in the first place that all weird cases should be should boil down to the same behavior actually. So it's something we were thinking about, but we are not sure about it. So that's why we ask for feedback. So okay, I'm taking note about that. Any comment about what Wesley just said?
Yes.
I agree with Wesley. I think that ignored info key, not consistent info key should be error and implementation defined behavior. Wrong info key is something different. So
okay.
Yeah, we should have something different. But I think that's the proposal that we have just below in the slides. I think it can fit there. Is if it's a wrong info key or ignored info key because you just don't know what to do with that. What do we do?
Yeah, I think it's the same case, I think, actually. So yeah. You have two weird cases actually: wrong, ignored, and not consistent. So in the case of wrong/ignored info key value, then I think that the most reasonable thing would be to provide a duplicate or a copy of the input com, not a copy of the handle.
Yeah. Do you want to ask people in the call about which option they prefer, or do you want to do a poll afterwards?
No, I mean, if people, so yeah, if people can answer now, that could be nice. Okay. So in case of wrong/ignore info key, what is preferable? To copy the handle or to duplicate the input com?
So I think that we have maybe 4 options for people. You have copy the handle, make a com dupe, return com null, or implementation defined.
Yeah.
That's something that we might not want, but maybe people do prefer this.
Okay, let me. Okay, so you said dub copy.
I would say
null. Okay, go ahead, Rolf.
Yes. Okay. In principle, MPI comnal we return if a process is not bound to this resource or is not restricted to this resource.
Yes.
Therefore, we should, and this was also the idea of this middle block. What should we do when we have wrong info key values? That's not the keyword is wrong, the key value is wrong, because it's from the other library. It does not fit to OpenMPI because it's from MPICH, for example. And I would really prefer to do this copy of the communicator handle, because the copy of the communicator handle is a zero-time operation, and also the MPI compare is a zero-time operation because it's only looking whether the handles are identical. And whereas a duplicate of a communicator, for this reason, is expensive, and with a duplicate of a communicator, then we have also this question: what do we should do with a key argument about the ranks, about doing new ranks? And whereas when we are doing a copy of the handle value, then it's clear it is a copy of the handle values. The key argument about the ranks is not used.
Okay, so a couple of comments about that. Why not? It's something I proposed earlier in the working group. So I think that about comnull. So I agree that comnull should be reserved only for unbound processes case and not used here, because there would be some ambiguity, and I don't want that. And then why I like the copy of the communicator handle is because it makes a clear distinction between this wrong info key value case and the case which is not a problem when you make a duplicate of the input com because you asked for it specifically, which can happen because you don't know that a resource type is an alias for another resource type. So I like that. For the record, Martin doesn't like this idea at all. So he told me it was very, very weird. I can read you what he said. He wrote, I am personally not in favor of ever returning just a handle copy. I understand why you suggest it, but it is really unusual for MPI operation and will confuse users. Okay, so that's Martin's take on this.
I agree.
Yes, but I agree. This means one must really tell the user that this is used to inform a user about this strange input values.
That's just error handling, though. I mean, if you want to tell the user there's an error, then tell them there's an error.
Yeah.
No, it is.
One concern with the comdupe also that we discussed in the work group, because we are split on this. So one concern we have in the work group on just returning the handle is that people are used to get new communicators and not just handle with such communicator manipulation functions, which means that they may manipulate this communicator, which is just an handle, at some point free the communicator because they think that they have created a new communicator and they are able to free it. And if it's only a handle to the communicator, they will end up freeing the original communicator.
And so maybe freeing API convert.
Yes.
So that was a concern. So as long, of course, as long as it's really written in the standard that's the behavior, people should know about the behavior and do something rightful to the standard. But it's just that we know people who use MPI, and if they are used to do something with communicators, they might continue to do it and end up doing some freeing stuff on the original communicator.
Yep. I would comment that we have only, I'm aware only of one location in the MPI standard where we have, by intention, changed an error into a strange behavior. And that's by reading behind end of file. Reading behind end of file is not an error, it is allowed, but then you cannot read the data and the status. You have to examine the status, whether the status tells, oh, you read less elements than you wanted to read. And with that trick, you can see, oh, I tried to read behind end of file. But in this case here, I would say it's better to throw an error because it's wrong input. And
yeah, but the problem is that that's inconsistent with how info keys are supposed to work. I mean, MPI is supposed to accept whatever value for an info key you throw at it, and if it doesn't know how to deal with it, that MPI is supposed to figure out something, and that's kind of implementation specific. Yeah. So while I agree that throwing an error is probably the best software engineering solution, and in a vacuum, that's what I would go for. I think in the case of MPI, we either need to say the result will be implementation defined, or we specify that it's going to duplicate the communicator. And then you'd still be able to check that. You could do MPI com compare. It would be slower than just returning a copy of the handle, but if you called MPI com split, you were expecting to take a certain amount of time anyway. It took that amount of time. Probably took a little less. Dupe is probably easier than split.
But dupe you would also do when the process is, when the input is in the way that it will not split the system.
Yep, you're right.
If you are running on a socket and your input is socket, then you also duplicate.
Yeah. But then again, in that case, you aren't going to get unexpected behavior. You're going to get the communicator you thought you were going to get.
Yes.
I don't have a problem with asking specific and having the result you want, giving the same stuff at the default behavior. If the results are the same, then the results are the same.
Right. So it sounds like we agree on the dupe behavior?
Yeah, it seems so. So there is, okay, just to sum up what we discussed so far. So just to be clear, in case of wrong or /ignore info key value, then we create a duplicate or a copy of the input com. It depends on the value of the key parameter, okay? Because if a key is not used, then we do a duplicate. Otherwise, it's a copy, and there is some rank reordering that happens in there, okay? And if the values are not consistent, then it's undefined behavior, okay? Is that what that's what I am understanding from the discussion.
Yes.
Okay. Tab copy, and sinon, okay, so that's good points. Undefined behavior. I'm taking notes, sorry. So what about the query function? So do you think that we should provide it right now, or would it be wiser to do that in a later in a later step? I discussed with Martin yesterday, so via email, and he was thinking that he was thinking about the unbounded case where a process is not bound to a resource is requesting for the split. Then you return com null, okay, because you can't do anything in this case. So he was thinking maybe it would be interesting to have a function, a very small, very simple function that gives you an information about the process, the resource type you want to use for the splitting operation. So I was thinking about something like the function that is at the bottom of the slide, something like MPI hardware subdomain type check, that would take as an input parameter the name of the that you are going to use for the splitting operation later, and then as an output two flags, one's usable and one occupied. So usable would be true if the calling process can be restricted to an instance of a resource of type name, and occupied is true if the calling process is actually restricted to an instance of such a resource. Occupied implies usable. So with this, if you have occupied true, then you know that the name you're going to use for the splitting type is going to produce a valid communicator. Otherwise, it's not going to produce to use it. So if you use it, you're not guaranteed to have a valid communicator. So because there were concerns for, once again, for the cost of the split type, and it would be maybe not instant. People might want to know beforehand that what kind of outcomes are going to get when you're using this. So what do you think about that? And this function would be very, very simple to implement. It's like it's like 10 lines of code with HWLock. It's a 5-minute work to do that. And it would be much, much easier to define as a function than the query function that I can show you after. So what do you think?
I do like that function. I would probably combine the usable and occupied parameters to just be one with an enum output instead of an int. But other than that, I like the function. I have questions about the query thing that I guess we'll discuss in a minute. But
yeah. So I mean, we can have both. I mean, I think that adding this little function would be quite straightforward. I mean, so to speak. But so it could be a nice addition. It could be very useful for people.
Yeah, I could see how this would be useful if you were trying to build functionality on top of this. It might be a little bit of a pain for users to go back and forth to query all these different things. But if you're trying to build a library on top of this that'll do some of this for users, that would be really helpful, I think.
Yes, and together with a routine that gives that returns all the possible names.
Right.
Yeah, but
the routine that returns the names, you have no input for this routine.
Yeah, I agree. You need to have both.
Yeah.
Okay.
You need both. But that's,
okay.
That's great that you can see already whether a process is restricted to an instance of.
In the current version of the query routine, you can know you can know. Well, there are a couple of designs, but in one design you can know that the resource is actually occupied or not. So you can have this information also in the query function already. So so the uses of both functions would be slightly different, but I think that both are useful. So, okay, so this function useful. Okay. And so Wesley says maybe an enum instead of 2 parameters.
Yeah, especially because they are, they're kind of increasing in value. The answer is either no, usable, or occupied. And the further up you go, it implies all of the things beforehand.
Mm-hmm.
Yeah, it gave also the room to have another value. Maybe we didn't.
Oh yeah, sure. Yeah, sure. I mean, I just wrote that in 5 minutes 2 hours ago, so I'm sorry, but I haven't much time to think about it. So is there some instances of functions in the standards as use enums already?
Yeah, I
Sure.
think so.
I mean, there's a bunch of enum values in the appendix something.
Okay.
Appendix A, I think, has some enum values.
Okay, I'll check that. Okay, thanks. So now about the query function. So the query function. So we had this discussion about should it be local or collective. So if we have, I'm going to show you the first version. So the local version. So the calling process retrieves a local view of the hardware, and it just uses as a nout parameter an info, and some keys are set in this info object.
So before
Yes.
you get into the local or collective question, I want to ask whether using an info object as the output for this is the right thing to do.
What would you use?
I'm not sure what the right thing to use would be. It may just be an array of strings or something, which brings its own set of problems. But this would be, just going back to precedent, I think this would be the first time we would be using info as an output object, where the implementation is defining values. I think we tried to do similar things with fault tolerance at some point in the past, where we wanted to provide output information, and there wasn't a great way to do that. And info keys or info key values were not something we'd done before.
Yeah, just a comment. I think that Rolf at some point told me that maybe I did not understand well what he was saying, but that array of strings is not really Fortran friendly, I think.
Oh yeah, I know. We're having that whole discussion on info string, and definitely arrays of strings bring a lot of other problems. I guess the question is, do we want to do that, or do we want to make or have this new thing? Because it basically just means info objects are now a two-way, a two-way path instead of just the user providing information to the implementation. Now it would be the user asks the implementation for information, and the implementation gives it back via an info object. And I think that would be the
we have this. We have this in I/O, for example. If you are doing a file open, and then you are doing an MPI file get info, then you get info about all the keys and values that are set for this file.
Yeah, but those are keys and values that were set by the user, aren't they? I mean, we have the same thing with communicators in Windows.
No. In I/O, it must provide you with the info handle, which tells if you are doing an open with MPI info null, and then you are doing a get info, file get info for the file handle, then you must be provided with all info keys that are done by that implementation. This can be standardized info keywords and non-standardized keywords always with the current value used by the implementation. And that's a way you can check which info keys are there for for your parallel file system.
Okay.
And I did this years ago. It works.
Oh, I don't doubt that it works. I mean, I think this is still a little bit different, but again, I'm always fine with breaking precedent as long as we all know what we're doing.
Yeah.
And this is still a little different because you're not.
Yeah.
These are not info keys that the user can use to give the implementation information, but maybe that's okay.
That's here returning.
Right. These are only info key values that are meaningful for the implementation giving information to the user. If the user set these values and passed them back to the implementation, it would presumably ignore them.
Hmm?
Yeah. So maybe we can. Okay. So that's a question of the interface. So I don't. Okay. I don't know. My first move was to return an array of strings, but yeah. Well, we had discussion about that, and info was maybe better.
The other interface is that you have several routines, and with one routine you learn how many keys are there, and then for each index in this possible thing, you can retrieve exactly one value. It means one string is always, that's possible. We have a lot of routines doing one string. One string is possible, but an array of strings, that's really not possible.
Right. I guess I would say that the string manipulation problems exist in either case because the info keys are also strings and the values are also strings.
Yes, but for the info, you know there are the routines already there to retrieve all the values. Yeah. But I must leave. That's the problem. Therefore, I'm doing a short interrupt.
We can come back to that.
Yeah. About info objects in chapter 9, there is an important sentence. Each function that takes hints in form of an MPI info must be prepared to ignore any key it does not recognize.
Yeah.
This sentence in principle does not forbid that an info is used for another purpose than a hint. And I tried to read now this chapter 9 several times, and I always didn't find any sentence that forbids to use an info argument other than a hint. This means, in principle, we would be allowed to explicitly write for the case that this MPI COM split type is the hardware stuff, that in that case the info argument is not taken as a hint. It is taken as a required thing, and then in that case the info must contain this special value, and so on. I would say we can write that here's an exception, and this exception seems to be allowed based on chapter 9.
Yeah, I think you're probably right that it's not forbidden. It's just that this would be the first time that it's true.
Yes. And then we should write that it's rare in the MPI standard. We should write a rational at that location.
So you're talking about for the first part of this discussion where we were we were saying that info key. Yeah. I mean, I still think I would prefer to stick with what we discussed and say it's not required, and we will do, not say that it's not required, but to say that it's...
No, if it provides wrong values. Wrong value, when the value is wrong, we must not allow wrong values, and then we must write a rational. In this case, the info argument is not used as a hint. It is used as to provide an explicit information.
Yes, but in the current text, it's not a rational, but it says that it's not a hint. It must be provided. It says the text explicitly says so, but maybe we should add some line saying that it's an exception of.
It's an exception that in most cases, infos are only used for hints.
Yeah.
Yeah. In fact, the very next sentence right after the one you read, Rolf, kind of explicitly says this. The description of info objects does not attempt to define how a particular function should react if it recognizes a key, but not the associated value. So that explicitly says, we're not saying what could happen, so we could define that wherever we want.
Yes.
And that's, that's permitted by this sentence.
Yes. Okay, I must leave. Okay.
Okay,
bye-bye.
Thanks, Rolf. Bye. So I think that what we like to do is actually to kind of generalize the MPI get processor name function. That's pretty much what I would like to achieve with this routine here, but with more information, of course. So let's put aside the interface for now, and should we use an info or not for this purpose? But just to ask to get some feedback about the design function. So of course, if you use this function, the information you can get can be outdated in the future, especially in case of process relocation. So relocation is a global word for either process migration or binding changes in the future. So there is an advice to users, or we should write one saying that the info return might be outdated in the future. Okay, there is already some text for the guided mode saying that when you're restricted to a resource, this restriction might change in the future. But it's the same issue with the MPI get processor name or with MPI com type shard already, and there is not a lot of things that is written about that for these cases. So I think we should put something about that explicitly, just to warn people. There is other places in the standard where this is the case, and it's not specifically said. I think that for MPI get processor name, it says at the moment of the call. So it gives this slight information that it's at the moment of the call, meaning that it can be false information in the future. So there are two possible designs. One is to return the types to which the calling process is currently bound. So that's a first way to go. And so in case of change your binding of processes, there is some missing information potentially because the information is outdated. Because you don't have all the level to which you can split to. And maybe you need to call the function again. But the nice thing is that all types that you get are guaranteed to produce a valid communicator in the case of hardware split in guided mode. So that's a very nice feature. And the other version, which is the one I prefer personally, is to return the types to which you can the calling process can be eventually bound. And then it means that some types are not currently usable for hardware split in guided mode, and but you don't need to call this function again, except in case of process migration. because the information is only local. And if you change of a node, if in case of heterogeneous hardware, maybe you might need to call this function again in that case. It is this information is currently what you can get with HWLock currently. So it's in line with HWLock. And maybe if we add a new key, MPI res I occupied to explicitly say that the calling process is bound to resource type number I in the list of returned resources. So it's currently what is implemented in my own library. I implemented this version, and so people can use this prototype version of this routine if they want to use it. So what do you think about the local version and the various designs possible?
So I'll cover the second one first.
Yeah.
I agree with you. I prefer the version where you return anything that may eventually be bound, because the first one is essentially that one anyway, because as you said, things can change at any time. So all you're saying is this was true at some point between when you first called this function and now, and it may still be true, but it may not. So you're essentially providing the guarantee of the second option anyway. So why not just say that that's what it is, especially because you are going to add that other function that lets you find out all the information the first one's going to give you.
Yeah. Yes.
So I agree. Second one's better. As for collective versus local, what would be the need to make this collective?
Okay, the collective, it would be, for instance, to gather some information about other processes located on other nodes. So you wouldn't have to call this routine again. You would have all the information for all the hardware, and then you don't have to call this routine again. So there were some discussions for HWLock. Should HWLock only provide some local information? Could it be interesting to have a distributed version of HWLock? I don't know what is the current status of the discussion, but we had the same kind of discussion here. So to me, it's a very much more complicated design. The implementation is going to be very difficult, I think, of this, and the use of this, I'm not so sure. So because you want to have this information in case maybe if you want to migrate processes, but if you want to migrate processes and if you do so, maybe you just can call the local version again, and then you're all set. So it was something we discussed in the working group, but my preference is goes toward a local version because I think it's.
I think I agree with you on that as well, because if you really want, you can construct a collective version on your own with just regular collectives. You can do all reduces to make this happen.
Yes. So
a reason to punish the user that doesn't need the collective behavior with the performance or penalty.
Yes. So I think that you're right. You can construct your own collective version with the local in the first place. So. And here it would be a very costly function, I think, because you would have to check for what is different from one node to the other, and make sure that everything is consistent. And I'm not sure how to present keys in the info object. It's well, I
was going to say, what are you going to do? Return a string with a list of process ranks? Yeah, just.
So that's why we were thinking about, but we had this discussion, so we wanted to have some feedback here. We were not sure about local versus collective call, so I'm presenting this today, but well, that's what we were thinking about. And maybe just one question about the future unguided mode. So we make the assumption that the hardware is hierarchically organized. So the question is this okay? Is this detrimental to the proposal? Well, it's how this mode is working anyway, I would say, but I don't know if people are freaking out when they read hierarchical hardware in the standard or not. And one other question: if we implement this, if we do this, should the implementation set the name of the output communicator to help identify what is created? So keep in mind that it's not always possible. Yes. Yeah.
Sorry, I have to leave. I had just one comment on that.
Yeah.
You say that the ungated mode make the assumption that the hardware is hierarchical organized.
Yeah.
I thought that what we discussed in Zurich is not that it is hierarchically organized, is that we can represent it as hierarchically organized.
Oh yeah.
I think in the text it said that it assumed that it is represented as hierarchically organized, and then we will go down this hierarchy by doing the unguided stuff. But it does not assume anything on how the hardware is. It assumes on how we can represent the hardware.
Yeah. Okay. It's maybe it's a bad wording from me. Okay. It's probably more.
I think it was. I think it was what bothered people in Zurich is that we assumed that it was hierarchically organized, and then we specifically said that we did not assume that it's
so maybe
but we can represent it like that.
Okay, maybe a better wording would be to say that in this mode, the implementation presents the hardware to the application as hierarchically organized, which is a little bit different.
Yes.
Okay. We agree. It's bad wording for me. Sorry. And so should the implementation set the name of the output communicator? It's not always possible in case of heterogeneous hardware or binding, but if it's possible, maybe it could be interesting because people were having issues with unguided mode, saying that you don't really know what is happening, you don't really know what you get. So I've been playing around with get info or set info, and it's really awkward. It doesn't do what I wanted to do. It's not. It might not be. We might not be able to achieve what we want with these routines. So maybe setting a name for the output communicator would be a way to go, because it's quite simple to call MPI get name afterwards after the communicator creation. So do you think that it's something that we should specify or not? Can you hear me?
Yes.
Okay.
No,
it was
a good idea.
Everything was freeze for a moment, so I thought that people were not hearing me anymore. So I think. So do you want me to show you the text for the routine?
This is the text for which routine? Sorry.
For the new. Okay, so maybe not the text for the new routine, because. So do you want to see the text for the guided mode as it is right now, or is it okay?
I don't know if you're going to have time to go through all that. I mean, I guess we have half an hour, but that's going to be a very complicated.
Yeah, maybe, probably. So I had some very nice feedback for now, because there are couple of questions that we answered. So we are going to modify the text accordingly, and to put this on the pull request and modify the pull request and the issues, text issues again. I don't know. I think that we have the feedback that we wanted to have. Do you have more questions about that? About what I presented today? What about the current version of the tickets and?
You got through all of my notes.
Come again, please.
I was just saying you made it through all of my notes, so I don't have any more questions.
Okay, good. So does anyone has more questions? So maybe in this case we can call it a day, and I will maybe send email to the mailing list if we have a more specific question in the future. Or maybe take some time during another virtual meeting, a couple of minutes, just to ask a couple of questions or two if people, if you want to have for some feedback. I don't know if it's possible or not. So I don't know what is the current schedule for other virtual meetings.
Yeah, I'm not 100% sure myself. I think we still have some open times, but I'd have to go look at the
Okay.
list.
So what is the deadline for the tickets, for the various tickets? It's the end of November, right?
So the official deadline, so let's see, our meeting starts on December 9th. So that means the official deadline is November 25th. The problem is that is the week of Thanksgiving in the U.S., which means it's going to be very hard to get many people from the U.S. to participate in much that week. And before that is SC. So we've kind of informally said that the last virtual meeting that we're going to hold will be on the 13th of November.
Okay. Yes, I agree for the virtual meeting, but for the deadline to have the text ready, it's still the 25th, right?
Oh yeah, the deadline to announce things on the mailing list is November 25th.
Okay. So that leaves still 1 month to produce some text and to make some changes. Okay, good.
Right.
Okay.
Of course, if you want to have feedback, announcing it ahead of time is good, so you have time to incorporate and all the usual caveats. So we do still have two time slots available in the virtual meeting list, but it just depends on whether some of the other big proposals need that time as well or not. I don't know if they do.
Okay.
So yeah, you just send an email to Martin and I, and we can try and figure that out.
Okay.
If you want.
Okay, I'll do that. Okay, thanks.
Okay.
So I think we are okay for now.
I think so. We can go ahead and wrap it up.
Okay, thanks.
Thank you.